watchful eye on Greenland, tracking changes in the thick sheet of ice that covers most of the island. Why? Well, for the same reason that coal miners used to bring canaries into the coal mines. If they stopped singing, it was a warning sign that trouble was coming. Greenland's ice sheet is one of Earth's canaries when it comes to global warming. Polar regions are more sensitive to a warming Earth than other parts of the world. So what happens in places like Greenland, the rest of the Arctic, and Antarctica alerts us to what's in store for the rest of the planet. And Greenland's ice can also affect many of us directly. You see, Greenland has more land ice than any other place except Antarctica. If it all melted, it would raise sea level around 23 feet. That's enough to put coastlines throughout the world underwater. And in fact, the ice is melting. It's far from all gone. That could take centuries. But Greenland's ice sheet currently adds about 250 gigatons of water to the ocean every year. What's a gigaton? It's 1 billion tons, which is approximately a block of ice 1 kilometer square. And 250 of these giant Greenland ice blocks melt every year. All this extra fresh water from this melting ice could also change circulation patterns in the ocean and in the atmosphere. Which means, even if you don't live near the ocean, a melting Greenland could potentially affect your local weather in the future. Eye on Greenland, tracking changes in the thick sheet of ice that covers most of the island. Why? Well, for the same reason that coal miners used to bring canaries into the coal mines. If they stopped singing, it was a warning sign that trouble was coming. Greenland's ice sheet is one of Earth's canaries when it comes to global warming. Polar regions are more sensitive to a warming Earth than other parts of the world. So what happens in places like Greenland, the rest of the Arctic, and Antarctica alerts us to what's in store for the rest of the planet. And Greenland's ice can also affect many of us directly. You see, Greenland has more land ice than any other place except Antarctica. If it all melted, it would raise sea level around 23 feet. That's enough to put coastlines throughout the world underwater. And in fact, the ice is melting. It's far from all gone. That could take centuries. But Greenland's ice sheet currently adds about 250 gigatons of water to the ocean every year. What's a gigaton? It's 1 billion tons, which is approximately a block of ice 1 kilometer square. And 250 of these giant Greenland ice blocks melt every year. All this extra fresh water from this melting ice could also change circulation patterns in the ocean and in the atmosphere. Which means, even if you don't live near the ocean, a melting Greenland could potentially affect your local weather in the future.
Good evening, everybody. This is Sandy Schoelles and Jennifer Hynes, and welcome to Environmental Coffee House. I am working on getting the chat for YouTube to work, but Jennifer, I'm happy that you are here with me. It's a very busy week, and I hope you guys like the video. We'll put it on at the end as well. We shared this all over. So far, only on the chat, I just see Facebook again. So while Jennifer starts the first article tonight, I'm going to work on fixing that behind the scenes. So take it away, Jen. How are you?
I'm doing good today, Sandy. And, the world is falling apart, comme d'habitude. We're living in an amazing time. What can I say? I just want to give people an idea of where we're going tonight so they can kind of set expectations. So we're going to start out with an article from Vice, and it's called Climate Change Predictions Have Suddenly Gone Catastrophic, and this is why. Vice puts out really good publications, so you'll enjoy that. And then we're going to have a tipping points show, and we're going to start out and we're going to see how far we can drill down into these 9 tipping points. These are basically the falling towers of climate change. So we're going to start out, and this is a 5-part series that came out in Carbon Brief at carbonbrief.org. And Sandy is going to post all of these links and titles in the show notes. But basically, we're going to talk about the 9 tipping points that could be triggered by climate change. And so we have a couple of guest posts that are going along with that. Could the Atlantic overturn circulation shutdown? That's one thought. The irrevocable emissions of permafrost tipping point. So we'll drill down into permafrost a little bit. Mm-hmm. Could climate change and deforestation spark Amazon dieback? And then we'll cover a little bit about Amazon deforestation for January record. And then we'll close with how close is the West Antarctic ice sheet to a tipping point? And this has a supporting article. A huge iceberg just broke off West Antarctica's most endangered glacier. Mm-hmm. And if we have time, we'll talk about a few climate models are now predicting an unprecedented and alarming spike in temperatures, perhaps as much as 5 degrees Celsius damn scary.
Mhm.
And if we have time as a bonus article, we'll talk about there are rivers in the sky drenching the U.S. because of climate change. So we've got kind of an action-packed, fairly nerdy show. So with that, it is, but I wanted to give people the 30,000-foot view before we got started with all of this, so you could have an idea as to where we're going and kind of get prepared for the flavor of the show.
And you keep doing it while I try to fix these comments, Jen.
Oh, okay. Well, just a sec. Okay.
We'll both
It's
take
the
our
coffee
sips.
house after all.
Okay. We'll have our sips of coffee. You know, it's the one thing I did not check was the comments that they were going to work, and now I'm not remembering exactly how to fix it. But
oh well,
it's okay. It's okay. I'll get there. I'll get it fixed, and everybody enjoy. Well, Jennifer's
all right.
doing
So
her thing.
I'll just kind of go ahead and get started, and Sandy's going to work her magic in the background. By the way, I'd like to give a big shout out to Sandy of Sandy Schoelles for figuring out this green screen technology. We hope it's going to lead to a more enjoyable and action-packed show than visually stimulating and engaging and all those things that we like.
My secret is Brian Weinstein from Head in the Box taught me how. So pretty much.
Nice.
Yeah.
Thank you, Brian.
Yeah.
We appreciate it.
All right.
See
So
what kind of trouble we can get into.
Let me work on this thing.
Pray for good reception. Pray for no internet glitches. Not that we've ever had those in the past.
No, but pray I can get these comments figured out why it's not working.
Yeah.
All right. I'm in the live control room. We'll see what
right,
happens.
Sandy.
Hope I don't screw it up. Okay, guys.
All right. So let's go ahead and get started. So this first article in Vice, it actually came out February 7th of this year, 2020. So last week. And, you know, climate change models are so interesting, and they try and take into consideration like all these different factors, you know, like all these different levels of things, and they're very mathematical. They have to run on big computers. It takes up a lot of, you know, cognitive space, and every so often you find out, oops, but I forgot a really big thing. So the oops, I forgot a really big thing in the climate models is this Vice article. And I think you'll find it pretty engaging. I certainly did. Climate change predictions have suddenly gone catastrophic. This is why. And this is about a factor that they forgot in the models. The latest climate change models have unexpectedly started to predict nightmarish warming scenarios due to this thing that they forgot. Now scientists are scrambling to understand why and if they can be trusted. So suddenly scientists are confused. That's never really a good sign. So I'm just going to read you like the first paragraph, and I think you'll find it interesting. I'm going to tell you it's about clouds. What would happen if the Earth's temperature went up a couple of degrees, or if carbon dioxide emissions doubled? All signs point to terrible effects from widespread heat waves to negative impacts on biodiversity. Now scientists' predictions have unexpectedly gotten worse. Never a good thing. Some models have even predicted temperatures in excess of 5 degrees Celsius if CO2 emissions, which are setting records, double. An increase of just 3 degrees is expected to be devastating for humanity. Not good.
Wow.
Yeah. In a study of these recent models, researchers found a surprising reason for the change, and the mystery is clouds. We talked about clouds last week. Isn't this a coincidence?
A coinky-dink.
Yeah. Dink-a-dink-a-dink. Oops, something about clouds. We forgot about clouds. Climate. I shouldn't be so glib. I really do apologize. I'm not nasty.
It's okay to be glib every now and then. We're living in such serious times.
It's just I feel like I'm living in such a surreal reality, and I
We
kind of
we
am
are.
getting sort of jaded, which
We
is never a
are.
good thing. But I mean, you just read all these things week after week, and you're putting it all together, and you're saying, "Oh my God, it doesn't look good." So here we go. Climate modelers rely on a centralized set of guidelines that enables comparison among their models. The models from this generation will be used to inform this year's Intergovernmental Panel on Climate Change report. So it's like, okay, so the IPCC also doesn't have this in it, and shape policy decisions to mitigate climate change. Right. Well, it's good that we're catching on to this part. The
Mhm.
world is already worryingly close to the temperature limits set in the Paris Climate Agreement. So the predictions of the latest climate models come as dire news. So not good. Basically, this article, which I found very interesting, Vice is always very good, is about how clouds really impact the existing models and putting in the factor of clouds and all the extra humidity that's going to be hitting us as the temperatures escalate. Like for every degrees we talked about last week, it's 7% more water vapor in the atmosphere, and it's a lot of energy as well. So you can just imagine what might happen. Mm.
It's kind of crazy, huh? Well,
Mhm.
I'm gonna move put us back on. So we were looking at that and I tried to
Mm.
fix it, and I'm sorry everybody. I don't know why. It's because I didn't go in before and make sure that this one little thing was clicked and I can't figure it out, but we can get all the we can, like Mindy from Facebook's on. We can get Mindy on from
Oh,
Facebook. Be sure
good.
to hit like. But I will have to read any comments from YouTube tonight. I'm really, really sorry, guys. One of these days I'll get every single thing perfect,
But
which
you know
then,
what? It's like each week we take like 3 steps forward,
yeah.
right? We might take a step back.
Well, I
It's
just
not
took a
like
step
so we're
back.
kind of like those climate graphs, right? We're going up ever so slightly,
Yeah,
but we have little glitches here and there. We're not a perfect
yeah.
system yet.
I
We're
know.
trying.
I know. I know.
We're
Well,
trying.
tell me when you want me to pick up, and then
Oh, sure.
when you're ready for me, I will pick up. Do you want to finish this one,
Well,
or
I
did
think
you want to
that
move on?
that's pretty much it. I think we should sort of roll along, but just know that clouds are a very important factor in the overall calculation and the models for having accurate models. And what I keep noticing every single week is that oops, the climate models were way too conservative because we didn't take into account this thing or this thing or this
This
thing,
thing.
you know? So this is yet another really big thing that they didn't take into account that the IPCC has never addressed. And I believe the IPCC has finally lightly acknowledged the methane threat, which I think is progress on their part. It would be nice to have all of the feedbacks caused by the melting of Arctic methane. Maybe we'll get there someday, but we'll see.
Maybe we'll get there someday.
Right.
Yeah.
Right. So, Sandy, do you want me to launch off this tipping points article, and then we can
Yeah.
kind of switch off like the guest post responses on the tipping
Mm-hmm.
points? Does that
Yeah.
sound like a good thing?
Yeah, it's a
Okay.
this article is incredible, and it's got the all the parts to it, and it's really a uh
Hmm.
it's quite packed with information. So let's Jed do the quite
Hmm.
packed with
Yeah,
information part.
it is. It's all packed full of information. Get ready.
Yeah.
All right, it's going to be a bumpy
Okay.
ride. That's all I can say. It's going to be a bumpy ride. It's not going to be
Right.
fun. Yeah. So this is basically an explanation, and it's a 5-part series that's come out recently in Carbon Brief. And it started just this week, February 10th. So if
Mm-hmm.
you go to carbonbrief.org, it's in the explainer column, and it goes on for several days. And we were really fascinated by it. And it basically drills into all the different tipping points. So 9 tipping points that could be triggered by climate change. So I'm just going to read a couple of the first 2 articles because I can't really state it any better than they say it. The persistent march of a warming climate is seen across a multitude of continuous incremental changes. CO2 levels in the atmosphere, ocean heat content, global sea level rise, each creeps up year after year, fueled by human-caused greenhouse gas emissions. And while climate records are routinely being broken, the cumulative impact of these changes could also cause fundamental parts of the Earth system to change dramatically and irreversibly. That just doesn't sound good. I'm sorry, guys, it doesn't. It sounds scary. These tipping points are thresholds where tiny changes could push a system into a completely new state. So they're talking about sudden things now. They're talking about, when we talk about abrupt climate change, this is kind of like catastrophic abrupt climate change. And the thing is about catastrophic abrupt climate change is it happens rather suddenly and unexpectedly. So here's an analogy that they use about it. Imagine a child pushing themselves from the top of a playground slide. There is a point beyond which it is too late for the child to stop themselves sliding down. Past this threshold, and the child continues inevitably towards a different state at the bottom of the slide rather than the top. So they're using this analogy called tipping towers as an example of how we could enter into sudden abrupt climate change. And I thought it was pretty interesting analogy. They have this Jenga cube. It's basically climate tipping points are a bit like a game of Jenga. And I don't know if anybody ever played this. There's like a tower made of all these little blocks, like these little oblong blocks in different patterns, and you try and take out some of these blocks, and then at some point the whole tower sort of collapses. So basically what they say in the game of Jenga, the tower collapses in a split second. For a component of the Earth systems, the shift to one physical state to another may take many decades or centuries. But the feature they have in common is that once the collapse has started, it is virtually impossible to stop.
Wow. And that's where we are. I mean, that's really where we are. Wow.
Yeah. It's scary, right?
Yeah.
One other thing they are talking about, this sequence of events that we find ourselves in our predicament witness to. So this section's called irreversible change. It's a little bit further down. The theory of potentially abrupt climate change in the Earth system is not new. In a Nature commentary in 1987, for example, Professor Wally Brocker of Columbia University warned that paleoclimate data suggests the Earth's climate does not respond to forcing in a smooth and gradual way. Yeah? Rather, it responds in sharp jumps, which involve large-scale reorganization of Earth's system. That's interesting, I thought.
There's a video in here about the climate tipping point with,
Oh, yeah?
do you want me to play it? I don't know how old, I'll play it for everybody.
You
Why
can give it a
not?
shot. I
All right,
watched
let's
it.
see if it, let's see if it goes. Let's see how it works.
Okay.
Okay, it's on the screen. I don't know if we can hear it.
A climate tipping point, or any tipping point in any complex system, is where a small change makes a big difference and changes the state or the fate of a system. Now, in the climate, we've identified a whole range of potential tipping points that we could cross as human activities drive greater and greater climate change. So they range from tipping points in ice sheets like on Greenland or West Antarctica, where you trigger their irreversible meltdown, to tipping points in the circulation of the atmosphere or the atmosphere coupled to the ocean. So a famous example is the possibility that we trigger a collapse of what's called the overturning circulation of the Atlantic Ocean, which at the surface includes the Gulf Stream, which transports heat to Western Europe and gives us relatively mild climate, including here in the UK. And finally, there are tipping points potentially in the biosphere, in the living parts of the planet on quite large scales. So an example might be the possibility that we could tip a wide-scale dieback of the Amazon rainforest, for example.
Wow, that was pretty good.
Yeah, tell you
Yeah,
what.
and then it goes on. It
Just-
goes on. Do you want to stay on this one, or would you like to go to the
What I'd like to do is just kind of allude to the next ones, kind of just say, you know, where we're going, because we have a few of them, and then we'll just kind of go through them one
Okay.
by one. Like, first one is just we're gonna talk about the shutdown of the Atlantic meridional overturning circulation, also known as the AMOC, the
Mhm.
system of currents Atlantic Ocean. So
I'll
that's
never
the
forget
first.
learning about the AMOC. I didn't even know what it was
Right.
in 2017, and
Right.
now I know.
Yeah. So that's like the first tipping point that we're going to drill into. So that's not small.
No.
And then let's see, the second one we'll do is the West Antarctic ice sheet disintegration, I believe. Is that what we were doing? Yep. And
Yeah, I've got a few of them. Okay.
yeah,
Yeah,
actually,
from the
yeah,
14th. That's
we're going to
today's
talk
guest
about
post. You-
I'm sorry, guys. We this is different than the articles order, so we're just going to go in the order we're going to go in. So the next thing we're going to talk
You just tell me, Jen.
is permafrost tipping point, and the next thing is, could climate change and deforestation spark Amazon dieback? And then the next thing is, how close is the West Antarctic ice sheet to a tipping point? So those are the 4 tipping points we're going to talk about today. So, Sandy, do you want to talk about the first
Yeah.
one?
Which one do you want me to pull up? The
Atlantic turning circulation shutdown.
Okay, here we are. I'll start with the Atlantic meridional overturning circulation, known as AMOC, is one of the major current systems in the world's ocean and plays a crucial role in regulating climate. It is driven by a delicate balance of ocean temperatures and salinity, which is at risk from being upset by a warming climate. Now, the latest research suggests that AMOC is very likely to weaken this century, but a collapse is unlikely. However, scientists are some way from being able to define exactly how much warming might push the AMOC past the tipping point. And then they talk about overturning. And there's a figure below, which actually, Jennifer, do you see it as I go up? It talks about the illustration of the AMOC. And in the North Atlantic, warm water from subtropics travels northward near the surface and cold, and hence more dense water is traveling southward at depth, typically 2 to 4 kilometers below the surface. So in the north, the warm surface water is cooled by overlaying atmosphere, converted to cold, dense water, and sinks to supply the deep southward branch. Elsewhere, the cold water upwells and is warmed, resupplying the upper warm branch and completing the circuit. So you can see the schematic of AMOC on the screen. And the red pathways show warmer water near the surface, while the purple pathways show the colder, more dense water moving at the depth. And this was from the Met Office, which carbon grease is good.
And the main thing that's happening here with the shutdown of the AMOC, which it has slowed over the last little while, is the melting of the Greenland ice sheet. So salty water is much heavier. So hot, salty water is actually getting pushed to the ground, and it's really covered with cool, light, fresh water coming off of Greenland. And it's basically creating this cool water ball right under Greenland.
Mm-hmm.
And that cool water ball is kind of standing up like a wall to the natural flow of the AMOC. And so it's starting to slow, and that's going to really, as the AMOC slows, that's really going to affect the climate in Ireland and in England, especially because they're currently warmed by the Gulf Stream and the
Mm-hmm.
AMOC, and it kind of wells along and it brushes the top, and it gives them a much more temperate climate than they would have. So it's going to affect a lot of things, God knows, but it's a huge thing that's happening right now.
It's really
That's for sure.
amazing how much you do know, Jennifer. You really do. You don't even need the articles. You really don't.
No, it's
But
it's well, I don't know. It's a lot of us feel a huge obsession. I mean, I consider this study of climate and putting all the dots together, part of a human awakening experience that a lot of us are all having.
mm-hmm.
And there is a certain compunction to look at and absorb information about this topic and seek it out. And consequently, it all kind of gets stuffed away. And I bet I'm far from the only one, who's looking at this like
No,
this,
you've got it. You've got it. But they go on here, and they were talking about the
Yeah.
thermohaline convection with the two stable, and this was from 1961. The
Oh my
article
God.
points out that they were talking about this thermohaline convection with two stable regimes of flow. So they were talking about how it worked, but they didn't. I'm going to go back to the graphic because. All right, let me get us off. I'm going to go back to the article and pick up with this figure. There's a figure below, and circulation strength, present rate, tipping point, and a collapse state. And then it's freshwater input and circulation strength. And what it is it's illustrates different possible AMOC states. So in today's climate, temperature dominates the cold, dense, high latitude. Water drives a strong AMOC red curve. But in the other climate states, it's possible for fresh water from rainfall or ice melt to freshen and so lighten the high latitude water. In this case, the water is not dense enough to drive the AMOC, which collapses, and that's the blue curve, which I'm going back to show everybody. And those of you that it says tipping points and hysteresis of the AMOC, and this is called Stommel sample model. Possible states of the AMOC depend on the amount of fresh water input to the Atlantic Ocean. And we all know how much fresh water is coming out of the glaciers, right, Jennifer? I mean, we all know what's going on.
Absolutely.
And
Yeah,
I mean, even
that's
today
right.
in Antarctica,
It's freaking shocking, actually.
It's terribly shocking, and it just they have
Yeah.
long-term projections here with the AMOC that it's evolved. His ideas evolved over years, but the fundamental insight that they had is still relevant. There's evidence that AMOC changes may have played a role in some major climate shifts of the past. So why wouldn't it now, right?
Yeah,
And I'm up
absolutely.
to the part of I'm up to comprehensive climate models do not project a complete shutdown of AMOC, and I don't know if you want to take it from there, or do
Well,
we
I
want to
think
move
we
on?
have to kind of move it along because things
All right.
we've got a few more ones to
All right. Because
go
this one
through.
has.
But I think the takeaway points
Mhm.
to know is that it looks like the AMOC could shut down sort of like suddenly. I mean,
says
that's
it.
the point of this concept of tipping points. And
Mhm.
there's a lot of study and froth and ferment for some reason going on over at the University of Exeter in Devon. And they have a lot of climate scientists there that are very fascinated and doing amazing work. So colleagues at the University of Exeter have been exploring the possibility of developing an early warning system for AMOC tipping. So they're watching it so carefully to see what's going to happen, because they know that Greenland, well, as we talked about it last week and the week before, since 1992, the ice melt off of Greenland has gone up by 9 times. Nine times.
It's so
And
scary.
Right. And so what that means is that we're just actually starting the abrupt part of the Greenland ice sheet melt. I mean, it's still intact to some extent, but the thing about climate change and everything that happens in climate change is that it's exponential, and it's on a polynomial, trend line, which means that it's got a curve in it. And so that's like kind of the whole point, is that we're just starting. So like right now we're in 2020. What about in 2030? How many more times is it going to be than it was in 2020? So there's going to be more fresh water, really cold ice water going right to that right south of Greenland and making that really huge, cool pool. And every climate anomaly map that you look at, if it's like an ocean temperature anomaly map, you will always see a giant cool pool right to the south of Greenland, which of course is where AMOC makes its downturn naturally when it hits Greenland. But it's getting blocked now by this giant cool pool that's developing, and it kind of rams into it. And over time, it's going to have an effect on the entire ocean Atlantic, system, and it's going to affect a lot of things.
There you go. And now we have the next story tonight. And this one, Jennifer, is, are we doing the irreversible, the emissions of a permafrost tipping point? Okay, Carbon Brief did really, they did great. I'll start with this one if you want, and then you can pick up. And feel free to interrupt. Let me get this story up on the...
show that picture of that permafrost thing,
there we
right,
go.
where it says the irreversible emissions of a permafrost tipping point.
It's up. It's up.
Check that out.
Check
all
it
like
out.
Melting.
Oh yeah, we even have I have other pictures, but all right, I'll start this one, and then don't feel free to interrupt and pick up where I am, because you can explain some of the things between the lines. So there we go. And this was the permafrost thaw in the gates of the Arctic National Park in Alaska, that picture. Across vast swaths of the northern hemisphere's higher reaches, frozen ground holds billions of tons of carbon. As global temperature rise, this permafrost land is at increasing risk of thawing out, potentially releasing its long-held carbon in the atmosphere. Abrupt permafrost thaw is one of the most frequently discussed tipping points, and we do a lot, that could be crossed in a warming world. However, research suggests while this thawing is already underway, it could be slowed with climate change mitigation. Would be nice. Yes, what is irreversible is the escape of the carbon that has been and is being emitted. The carbon released from permafrost goes into the atmosphere and stays there, exacerbating global warming. And in short, what happens in the Arctic does not stay in the Arctic. And we even have a meme in Environmental Coffee House like that Mindy made. Permafrost and the global climate. Permafrost is ground that has been frozen for at least 2 consecutive years. Its thickness ranges from less than 1 meter to a kilometer. Typically, it sits beneath an active layer that thaws and refreezes every year. A warming climate puts this perennially frozen ground at risk. When temperatures rise, permafrost thaws, and it does not melt. Now, we've been talking about this, and I know this is kind of rudimentary for some of you that are with us, but it's always good to review this stuff. It really is, because everybody's knowledge level is different. So there's a simple analogy. Compare what happens to an ice cube and a frozen chicken when they are taken out of the freezer. At room temperature, the former will have melted, leaving a small pool of water, but the chicken will have thawed, leaving a raw chicken. Eventually, that chicken will start to decompose. This is exactly what happens to permafrost when temperatures increase. 1/4 of the landmass of the northern hemisphere is underlain by permafrost, which acts like the Earth's gigantic freezer and keeps enormous amounts of organic matter frozen, which we know. And how many times have we talked about what's under that? And in this graphic
Mm-hmm.
I'm showing, it says continuous permafrost, discontinuous permafrost, sporadic permafrost, isolated patches, and subsea permafrost. And remember, guys, there's people living all over the permafrost, everywhere, and they're losing their homes and they're losing their livelihoods because of the melt. So the organic
Mm-hmm.
material, and this, this was one, the organic material includes the remnants of dead plants, animals, and microbes that accumulated in soil and were frozen into the permafrost thousands of years ago. So check that picture out that's on screen. Jen, you can see it on screen, right? Through your phone?
Oh, yeah. Well,
Okay.
I
Look,
mean, I'm just following along. I know
all right.
exactly where you are.
Well, if you
That's
look at that
incredible. That's
picture, yeah,
such a
look at
crazy
it.
looking picture.
It is. Look how, I mean, you really can just see it says 14,000 years in the bone underneath, and bone of what? Extinct animals. And it is pretty wild. It says ancient bones was in the left and organic material. I'm fascinated by it. And again,
Oh,
my bucket
yeah.
list is Greenland. And Jennifer, we're going. We're going.
Okay.
And if I have
Okay.
to bring all my neck brace, my back brace, and my cane and my gear, I'm going. And I'll just have a hiking cane. All right. Dream on, Sandra. Arctic temperatures have been increasing more than twice as fast as the global average. This has caused that permafrost thaw in many locations and triggered newly awakened microbes to decompose the organic material, thereby releasing CO2 or methane in the atmosphere. And remind me, I have to talk about this later, Jen. A show I was
Mm-hmm.
watching today, and the comment section and the disinformation of these people. I have to tell you, don't let me forget. I have to tell everybody. It was scary. Um,
Oh my
okay, so
God.
oh yeah. I mean, talking about, the permafrost is melting because of the sun, those kinds of things. All
Oh my
right.
God.
So anyway, both gases, we know that they're greenhouse gases. We know that methane is 28 to 36 times more potent because we talk about it over and over. So this, and then the carbon release. So what role will the permafrost play in the future? And is there a tipping point that could trigger rapid thaw? Well, yeah, the scientists estimate that there's about twice as much carbon stored. So we know this. We already know this. This article's like review for our class. It kind of is. At
Mm-hmm.
least maybe
Mm-hmm.
for what's going on here? Wait a second. I have to fix something. Okay, I'm back on. But they still said this would still be about one order of magnitude smaller than emissions from fossil fuel burning by the end of the century. But nevertheless, every additional molecule of CO2 or methane added to the atmosphere accelerates climate change and affects the whole planet. Look at that picture. That is collapsing permafrost. That's gross. I mean, it's sad. It's
Wow.
tragic that we're seeing this in our lifetimes, even though, most of us, well, maybe except for Torstein. I don't know, Torstein, are you here? I'm looking. But um, who's stepping on it, who's living on it. Um, but
Yeah.
but they say carbon release from permafrost is gradual and sustained. But then again, Jennifer, what about where we see those bubbling up?
I know.
That's a little different. They said recent research suggests that if temperature rise were to slow and stop, permafrost too would slow and potentially stop, but preventing further emissions. But that's not happening. That's not
I just think
happening.
these pictures of the permafrost are so stunning because basically what's happening is some of this land is like 80% water, right?
Look, we talked
And
about
it
that.
is really just going to be sludge as soon as it thaws. And
Yep.
then look at it.
Look
It's
at it.
just
The
melting.
thermokarst, like
It's
we talked
just
about
like a
last week.
freaking mush. And the thing about these tipping points, it's not like you can regain this land. You can't stop this from happening, and it's also kind of inevitable. And we're just starting to see like these massive, pieces of the land falling away. But basically what's going to happen is the whole thing is going to be like this. And the whole thing is going to be this nasty, rotting mush that's like the size of,
Yeah.
Russia or something. I mean, something crazy. I mean, it's huge.
They've got this down here if you want to go down the particular concern of the methane hydrates beneath the East Siberian Arctic shelf. And I know this is a repeat for a lot of people, but it's so good to go over it. It's that shallow coastal region north of Russia. The studies have suggested that thawing permafrost is releasing this methane. That's what we're talking about, letting it bubble up and out of the seawater. And it has led to research warning that escape of large quantities could have catastrophic consequences for the climate system. And of course, the methane time bomb. I mean, you did the movie.
Time bomb. I would like to point out, if I can just be so bold as to take over right now, because I don't know if you guys remember, but last year there was like this thing that Torsten had going on his page and his YouTube channel called Permafrost Wars. Yes. And basically it was a video that was put out by Yale Climate Forum, I think. Was that it, Sandy?
Yale Climate Connections.
Yale Climate Forum. And basically it was a debunking of the methane bomb, and it featured this really emotional, shattered girl, and it showed like all the bad methane videos that she had been watching that caused her to have a mental breakdown and basically be in an unstable and an emotional place. And she was very cute, but she was like having this big emotional breakdown. And then it was so funny because then they flashed to like all the bad methane movies that she was watching on YouTube. And it was basically like, Torsten and I he agreed to republish the demise of the Arctic, which was Methane Monster 2. And that was like this crazy thing I put together about 5 years ago or 4 years ago. And we republished it under his Going South YouTube channel. It's like 2 hours and 40 minutes. And so because it was published as kind of a premiere in YouTube, it started coming up in the searches. So one of the bad methane videos that this poor girl was watching was like Methane Monster. And I was looking at that. I was like, oh my God, look at that. Methane Monster's featured. I was like, and then this Carolyn Ruppel, the chief scientist for the U.S. Geologic Survey Gas Hydrates Project, this woman comes on and says, oh no, nothing like that could ever happen. And then she basically uses this very fancy language with like endothermic reactions. And of course, it just means melting. It's like heat's getting added to the system and eventually it's going to melt, But anyway, she basically tried to debunk the entire methane bomb theory. And she's doing it again in this article, PS. So now we're going to hear Carolyn Ruppel. You're right here. Okay. I'm about to read.
You know what, though? One of our followers, Sherhanik, she says Caroline's cool. She knows her. So actually, it's a small world out here.
Oh, my God. Well, maybe she is. Well, let's see what Carolyn Ruppel has. So
let's get it up there.
Much contested Carolyn Ruppel. She tells me that methane hydrates trap about 1/6 of the Earth's methane carbon, and that some deposits may in fact be degrading now as the climate warms. But, and here's the caveat, she says, if the methane released during gas hydrate degradation reaches the ocean, it would mostly be consumed by bacteria in the water column and not reach the atmosphere. I contest that. In permafrost areas, degrading gas hydrate is usually deeply buried. So permafrost thaw is one of the more important contributor to greenhouse gas emissions. So fancy speak for the methane bomb is not really a threat because it's going to, as the methane comes out, it's going to get consumed by bacteria in the water column. Okay, P.S. The East Siberian Arctic shelf is an average of 60 meters. There are methane fountains currently going off that have recently been documented by Igor Samoletov and Natalia Shikova, and they're more than a mile or a kilometer wide. They're absolutely huge, and they're gushing, and it's just like carbonated water.
Right.
And the water column is so shallow that they're just going to the top, and they're not being absorbed by the water column or eaten by bacteria on the way up. So I'm glad to hear that Carolyn Ruppel is a cool person, and I will reopen my mind.
Well, let me read this comment from Shurhana. Carolyn works at USGS. They are now upping the ante on the methane threat from permafrost and bubble lakes, and they are aware of this and publishing on it now. Thank you, Shurhana. I wish I could have put this up, but I screwed up again on these comments. I'm so sorry, guys. But that's great,
so
Shurhana.
Cool.
Thank you so much.
Well, I mean, not that I should be happy that there's so much methane in the world and that it's going to be such a threat in the future, but I'm really happy to hear that they're actually addressing this now, because I thought they were kind of whitewashing it before, but that's cool news. That's really good.
Let me see if I can get the chat up and see if YouTube popped up. Nope, I have to read it. All right, well, there's one more I wanted to read from Unstructured Understanding, and he asks, did she include deep sea methane oceans? Yeah, those. The change in deep sea flows could affect huge pockets. And then, well, that's a good question. And Edgar Reese said Beckwith did a number of videos about methane a couple of years ago back. We know those because we saw them. And we talked about it when we both, did you interview him? I did a couple of times. It's a combination of the rate of emission, bubble size, and depth. Small bubbles from deep water are consumed by bacteria. That's Edgar Reese. Thanks, Ed. And then Shurhana said, Carolyn says only stuff 500 m down is not a threat. The rest is a big threat.
All right. Watch this space.
Boom! Yeah.
Well, the mystery continues, and we'll continue to unravel this as it becomes apparent.
It's in there.
Yep. I know. Scary stuff.
It's in there. Yeah, we could put this one back up again and scare everybody with our climate change and oh gosh.
This is like the disaster show.
It fits right in. Yeah, it's a and thank you.
It's a disaster. It's a reality show, but it's real.
Shurhana said she's just clarifying, and of course she's wonderful, and we love Shurhana. So she's a researcher also, and she's wonderful. She is. Jennifer, you should get to know her. She's wonderful.
Awesome.
All right. So where are we going next? The next article?
So another tipping point. Do you want me to kind of take this away here?
Yeah.
This is about the Amazon.
All right. Let's get it up for everybody to see.
You got that one?
Yep. It's up on the screen now.
Okay, cool.
It's ready to go.
Right. So this one is another tipping point that is covered in some detail, and it has to do with the Amazon. And we know how important the Amazon is to our overall oxygen production. Granted, the different little sea creatures produce probably 50% of the oxygen, but the Amazon is a significant contributor and air purifier and oxygen producer, or has been, so the deforestation of the Amazon is a huge thing, and it affects climate in so many different ways. So here we go.
Absolutely.
Last summer, the Amazon rainforest was in the news again, and we all remember that when it became big news for all the wrong reasons. Deforestation rates are on the rise under the leadership of Brazilian President Bolsonaro.
Yep,
And
Bolsonaro. Hi,
2019.
Air.
Yep. And 2019 brought the highest number of forest fires in almost a decade. And think of all the fires going on in Earth. I mean, the amount of fires going on in the Earth right now, when it's almost any time of year now, it's absolutely stunning.
I've been looking at the
So,
fire maps that people have been
uh,
sending me on all these different NASA programs and things. It's very scary.
oh my God, so
Tonight's
scary,
buzzword, scary. I'm not really
scary.
scared though. It's scary, but I don't feel scared.
It's right. Well, I'm with
I'm
you.
numb.
It's weird, right?
It's weird.
So we know that the Amazon plays a vital role in the climate system, recycling water to help sustain rainfall in the region and drive atmospheric circulation in the tropics. In addition, destroying the forest would have a major impact on the atmospheric CO2.
Mm.
So, and not in a good way. So, basically, the Amazon helps to slow climate change. It's basically a carbon sink. It absorbs a lot of carbon from the atmosphere and turns it into trees, turns it into oxygen, all great things, keeps the water circulating. So the deforestation continues in the Amazon, and they cite this as one of the most impactful sorts of tipping points in the whole tipping point scheme, and it's going to have a disastrous downstream consequence on many different levels. And it's probably going to cause drought, and it's probably going to cause more types of climate events than we can even understand. Somewhere in this portion, it shows a graphic that I'm looking at right now of the Amazon rainforest, and it's absolutely huge. The natural Amazon rainforest stretches beyond Brazil, and it actually hits some of these other countries around it as well, and like Guyana and Suriname and Venezuela and Colombia, Ecuador, Bolivia, Peru. Its reach is far and wide, and cutting it down and turning it into wood products and palm oil land, or God knows what they're doing with it, is like the worst thing in the world. So I guess we should probably move along if we're going to get through this. This is sort of a depressing hour, isn't it? Do you want to say anything about the Amazon, Sandy? Do you have some things you want to talk about?
Well, my thoughts are more political, and I don't know if that's good for tonight. I mean, my thoughts are political in that Bolsonaro and Trump and, well, off the top of my head, all of the moving rightward people are all very much for environmental degradation. Let's just get everything we possibly can. And the one thing that I know that was going on in the Amazon with Bolsonaro had said that he didn't he was not the person that told him to go out and light fires. That it was just that it was more like a green light for agribusiness in Brazil, and let's just go. He didn't actually tell them to do that, and then it was out of control. But politically, the country, and I can't talk much about it. I mean, other than what I know as a fact from reading and learning, but there are probably two sides to the story. And just like in the United States, I'm sure there's a lot in Brazil, like those farmers, because there's a market for palm oil. Because
that's right.
It is the market for palm oil, all those oils, and they're not all so great. So that's my commentary. It's
Yes.
not much.
Yes.
I
I
just was
agree.
disgusted about the whole thing, because if these farmers had other opportunities and it was hemp, or it was something different than palm oil that's actually killing everyone in the West anyway,
No.
wouldn't it be, it would be a much better world. But we don't live in that much better world, so
No. No, we don't.
no.
We took a fork of reality and we ended up in like some nightmarish science fiction, day after tomorrow type of reality, where Donald Trump is president and our world is turning to Nazism and,
Oh my God,
this
guess
this
what? I have to
what
interrupt. Look at this. YouTube
what?
just started coming on the comments and
Oh,
Facebook
good.
out of
Excellent.
nowhere. I have no
Excellent.
idea. So I put okay, I'm sorry to interrupt you. That was a really
No,
good thought and
that's
I got too excited. And
yeah.
okay, well,
Hey,
go ahead.
Hey, let's move. I was just noticing the time, and we
Yeah.
have one
All
more
right.
tipping point that we really need to talk about because it's so interesting.
All right, you're on. Go.
Okay, how close? This is West Antarctica, guys. How close is the West Antarctic ice sheet to a tipping point? So you all know there are some like doomsday
It's 10
glaciers in
o'clock.
West Antarctica, Pine Island Great Glacier, Thwaites, and
I don't know where we
basically,
are.
yeah, I'm just talking, but I'm,
Okay.
Yeah. But basically, this is another of the Carbon Brief series that came out on the 14th of February. Happy Valentine's Day, everybody. So this is our Valentine's Day article, and it's all about West Antarctica melting down. Between its east and west ice sheets and its peninsula, Antarctica holds enough ice to raise global sea levels by around 60 meters. Do the math. That's a lot. And that's West Antarctica. Okay. Oh, that's Antarctica, 60 meters. The West Antarctic ice sheet, WAIS, West Antarctic ice sheet, is a relatively small part containing an amount of ice equivalent to 3.3 meters of sea level rise. So that's what, like 15 feet or something like that. Yet most of it sits in a precarious position and is considered theoretically unstable. I would say not theoretically. As a result, how the West Antarctic ice sheet will change in response to human-caused warming is generally thought to be the largest source of uncertainty for long-term sea level rise projections. So for some reason, they haven't been able to get their hands around it. But I think that time is coming to an end. The most pressing aspect of this uncertainty is understanding whether the instability thresholds of ice have been crossed and whether the retreat we are now measuring is destined to continue and whether ice that appears unchanging today will remain that way in the future. Well, I can guarantee you it's not going to remain the way it is today. The latest research says that the threshold for irreversible loss of the West Antarctic ice sheet lies between 1.5 and 2 degrees centigrade of global average warming above pre-industrial levels. With warming already around 1.1 C and the Paris Agreement aiming to limit warming to 1.5, well, there's a problem there. What's the problem there?
Right.
Well below 2C. I don't see that either. And they're saying, well, we are already near 1.5, and I believe that. The margins for avoiding this threshold are fine indeed. Well, that's delicate language for such a severe problem. So basically, this goes on and talks about the breakdown of the West Antarctic ice sheet. So I think that's this Carbon Brief. Everybody should go to Carbon Brief and just start taking a look at this article series. It's pretty darn interesting, and they keep adding to it with guest posts of these different tipping points that are being diagrammed. So I think it's still going on, right? This
So yeah, they'll
they're
probably
adding
keep up with it.
articles.
I hope they keep up with it. It's pretty good.
Yeah,
It's
it's pretty
pretty
good.
good. It's good, and it's good for not just, the experience to understand all this, like on Facebook when you go into Sam Carana's groups and everybody's rattling off numbers and all kinds of data and
Yeah.
all, and I'm like, okay, well, it's nice. This is Carbon Brief wants to talk to me,
Yeah, they
to me,
do.
to
They
me.
do.
And
They're not so nerded out that they lose you. Some of these scientific articles, you really want to read them. You know it's good for you to read them, and you can't read them to save your life. They're just like too nerded out, and they lose the impact of our predicament. And that's kind of what is getting like, you can get so into the mind and so into these tipping points and everything like that, and diagramming it out and things like that. That's good. And it's important to take on board all of these pieces and bodies of knowledge, right? And
right,
understand how they work together and things like that. But what can't get lost in translation is the inevitability of our situation. And basically, what a freaking special time that we're living in right now. I mean, we're living
it's an
we're
emotional
living in
roller
this.
coaster
It is,
every
and
single day if you let it be. I know. Hey, Jean's here from Costa Rica. Hi,
hey,
Jean.
Jean.
I think you, USA people think you are just children who can do what you want and it has no effect on the planet. Well, you know what, sweetheart? You're probably not off on that, and I wouldn't even argue with it. I wouldn't even argue with it because she knows. She lives in a different country. She lives in a culture that is not like this, replicating, buy, do. But the more the Americans go down south because they can't afford California, they're buying
Yeah,
up the property, and now these countries are getting built and more built by all the Europeans and the other people from all over the world that are coming down there because they can't afford California. It's terrible. It is.
yeah.
So let's see
No
what are
kidding.
people. You are a lying liar, serving up lies. Ooh, it looks like there's some controversy in the
Oh.
Where's my mods? I don't know. I'm gonna have to go look at all this. I'm
Is
definitely
this
gonna have to go look
is
at
this
all
some
this.
chat that's going on
I
that they're
guess,
having a
I
little
guess.
argument?
I don't
Oh
know. I
my.
don't know, but they can figure it out themselves.
Oh good.
Because as long as it's not ignorant, nobody's calling anybody's names. Oh, Shahana says we all agree there's a methane emergency. Yes, we do.
Okay.
Yes, we
Okay.
do. And
Okay.
yeah, we have been on for quite a while. Um, oh, Karen says yes, she's watched people buy Costa Rica. Yeah, it's happening. It's happening, and
Yeah.
they're all going to and they're going to build just like here until like the end. Wait a minute. She says Rupert didn't deny the methane emergency. Okay, so I think this guy, I can't,
Oh my
whatever his,
goodness, the permafrost wars continue.
yeah, it
You
seems
know
like in
what?
our
We
in
better
our
find that original, Sandy, we better find that original video that Torsten,
I'll put in a link.
did in response, a rebuttal to, and post it in this because we've been
Okay.
talking about it so much. We'll have to find that.
I will. I will. Oh, wait. He says lying about Carolyn Rupert's lies. Oh, drama in the chat room.
Ooh, they're talking about
Ooh,
Carolyn Rupert.
but
Oh my
drama.
goodness,
We
this girl's
very
getting quite a rap.
well, but our chat is very civil and nice. We
Oh,
don't get
that's
many
good.
trolls. We don't get too many like climate change deniers. We don't get ugly people, Jennifer. I think we're
Yeah.
pretty lucky that
I
we
think
have
we've got
such
a
a
great
nice.
community.
Yeah, me
Everybody's
too.
so considerate of
Me
each
too.
other.
And I think because we've been on over an hour, about an hour, that this
Yeah.
has been a really good it was a good overview through Carbon Brief of everything that we all pretty much know, but it's good review, and I enjoyed it. I enjoyed
I did
what we
too.
did tonight. We still had more, but you know what? We would be on all night going through because the news
Yeah.
now, where it's like,
You can't cover it
yeah,
all in an
remember
hour. Sorry.
2 years ago, we were sitting here going, "Oh my God," we were searching for climate change stuff. It's just
Yeah.
like, holy
No, now
crap.
it's like everywhere. It's
I
like the most
know.
popular topic.
I know. Oh my gosh.
Oh,
So, all right, guys. Well, Kent is here, and Kim is here, and Osama, and Book Hermit Jean, and let's see, Matt Nelson. Thank you so much for your contributions tonight. I'm sorry we didn't get to, get to your comments as much. It's hard to do all of this. I'm not a board up. I'm not a board up. Karen Reese and Humans here. So it was a very nice Book Hermit, very nice. Heidi Verthaler. Hi, Heidi. Thank you for coming. And really, it was a good night. CB, buddy. And he's saying Blake TV is live. Blake TV is a completely different kind of channel. If you want to have fun, go to Blake TV. It has absolutely nothing to do with anything but Friday Night Goofy. They're a bunch of lighthearted people from all over, really. And Shahana, thank you very much too for being with us. Jennifer, parting words.
Yeah.
Go ahead.
Well, I mean, I thought this was a good topic. I was so happy that Carbon Brief came up with this big series, and we just got to have a little drill down with it and review it. I think it's just kind of fascinating to watch the meltdown. We're all witnesses to everything that's happening. And those of us, knowledge begets knowledge. That's the thing, right? And it's good to live in a curious state of mind. So that's what we're kind of cultivating in each other in this community that's evolving. We're cultivating, a multi-dimensional state of mind, and we're also engendering curiosity, which will enable you to master these topics. And we're having quite a realization altogether, consequently, as we take all of this information on board and bear witness to the tragedy of this debacle that we watch unfolding around us. So that's kind of
witness.
Yeah.
So what I'm going to do is call out the Natural Progressive. Thank you for coming. She was here earlier. Torstein was here, green-pilled. Let me see if I can find his little thing to put up for a second, like I do all the time. greenpill.tv. Go there for your 24/7 climate videos and enjoy the fact that you don't have to choose, because they just play. Oh, and Jim and Tanya, our huge activists that are out there every weekend, and in Pennsylvania, no matter if anybody comes, we're listening. And they just said a real-time science experiment we are witnessing. Yes, we are. And at that, Jennifer, I guess I'm not going to talk about what I witnessed. Maybe I'll save it for in the chats. It's just scary, the ignorance that's out there, and the things that people are actually believing about what's happening. But could take me a whole other hour.
Well, that's like a whole show unto itself, and it dives into a whole different consciousness, doesn't it?
I like that consciousness, though. It's interesting to me, human behavior. But
if
I feel good enough this week, to do it, maybe I'll do it, because planning is not my forte, and this is amazing. The only way I'm doing this, Jennifer, I'm moving around, is that I have something to look forward to in my life, and it's you. And thank you, and all of you. Everybody knows I've been going through a hard, horrible time, and thank you. That's all. Just a love fest. Love you all, and stay for the video. I'm going to put it on now. Jennifer, good night. We have to
Good
keep
night.
up. It seems like the audio doesn't work, and everybody can hear us sniff and breathe when I put these on. I don't know why it does that.
We'll try and not do that in the future.
Please stay on this stream and watch this week's video production. Okay? Good night. Peace.
on Greenland, tracking changes in the thick sheet of ice that covers most of the island. Why? Well, for the same reason that coal miners used to bring canaries into the coal mines. If they stopped singing, it was a warning sign that trouble was coming. Greenland's ice sheet is one of Earth's canaries when it comes to global warming. Polar regions are more sensitive to a warming Earth than other parts of the world, so what happens in places like Greenland, the rest of the Arctic, and Antarctica alerts us to what's in store for the rest of the planet. And Greenland's ice can also affect many of us directly. You see, Greenland has more land ice than any other place except Antarctica. If it all melted, it would raise sea level around 23 feet. That's enough to put coastlines throughout the world underwater. And in fact, the ice is melting. It's far from all gone. That could take centuries. But Greenland's ice sheet currently adds about 250 gigatons of water to the ocean every year. What's a gigaton? It's 1 billion tons, which is approximately a block of ice 1 kilometer square. And 250 of these giant Greenland ice blocks melt every year. All this extra fresh water from this melting ice could also change circulation patterns in the ocean and in the atmosphere. Which means, even if you don't live near the ocean, a melting Greenland could potentially affect your local weather in the future. Eye on Greenland, tracking changes in the thick sheet of ice that covers most of the island. Why? Well, for the same reason that coal miners used to bring canaries into the coal mines. If they stopped singing, it was a warning sign that trouble was coming. Greenland's ice sheet is one of Earth's canaries when it comes to global warming. Polar regions are more sensitive to a warming Earth than other parts of the world, so what happens in places like Greenland, the rest of the Arctic, and Antarctica alerts us to what's in store for the rest of the planet. And Greenland's ice can also affect many of us directly. You see, Greenland has more land ice than any other place except Antarctica. If it all melted, it would raise sea level around 23 feet. That's enough to put coastlines throughout the world underwater. And in fact, the ice is melting. It's far from all gone. That could take centuries. But Greenland's ice sheet currently adds about 250 gigatons of water to the ocean every year. What's a gigaton? It's 1 billion tons, which is approximately a block of ice 1 kilometer square. And 250 of these giant Greenland ice blocks melt every year. All this extra fresh water from this melting ice could also change circulation patterns in the ocean and in the atmosphere. Which means, even if you don't live near the ocean, a melting Greenland could potentially affect your local weather in the future.